Okay, did we get this? No. Do you guys not know how to put it in your calculator? Okay. The vertex is the point where it turns. So if you have a parabola, the vertex is that point right there. What are the coordinates of that point? Okay, just work on it for right now. We'll go over it in just a second. You guys, by the end of the day, you should be able to get it without graphing. You should just be able to look at this and tell where the vertex is. Okay, that's what we're going to be learning. How many of you were able to predict where this parabola moved before? It says +2. How many of you guys were able to predict this before you put it in your calculator? Raise your hand. One person? Okay. We should be able to do this by the end of the day. Hey, by the way, how do you put this in your calculator? In case you don't know, parenthesis x plus 2, parenthesis squared minus 3. I always like to start off in a standard window. How do I get a standard window? Zoom 6. About where is it? -2, -3. How does that relate? You guys, look at this. All eyes right here. How does this relate? The vertex is at -2, -3, right? Went over 2 and down 3. How does that relate to y equals x plus 2 squared minus 3? If I raise a hand, who would like to explain that? Okay, Alex. Shifted down 3 because of the minus 3. Good. Left 2 because of the plus 2. Remember we were doing that task worksheet the other day? Remember that? Remember it went in the opposite direction we thought it was going to be? Okay. All right, right now, I would like you guys to finish up your task. So everybody get out that task worksheet. Hey guys, how many of you guys this stuff that we're doing does not make any sense to you at all? It's all right if you know. I just need to know. Is this stuff not making sense to you guys, what we're doing? It depends on which one you're doing. It depends on which way you want to move your graph. How many of you feel like you understand what you're doing? All right, good. Hey, even if you don't, what I want to say is even if you don't understand it completely right now, hopefully by the end of the day you will, okay? Because we're going to go over some stuff that will help you understand it. But I think it's important for you to do this part of it first so you can have a depth to it that you're doing. Whenever we do these tasks, this will help you understand it deeper if you'll do the tasks, okay? You'll start understanding things at a different level. You guys, on number 8, some of you, I mean, most of you guys all did this by hand, which is what I wanted you to do, but some of you put it in your calculator, which is fine too. I think there's things you can learn both ways, okay? But I want you to see this right here. If I put 2x squared in my calculator, there's the graph of it right there, okay? And if you compare, how does it compare to x squared? What happened? It's narrower. Good, yeah, it's narrower, it's growing faster, all that. If you go to second and window to table set, and -3 is a good place to start, or you know, maybe I'll even go a little bit lower. I'll go -4. And I'm going to go up in ones, so it goes up in integers. Okay, so it goes from -4 to -3, then -2, then -1. Okay, that's how much I count up. And now I hit second and graph. That brings me up the table. I have my graph, my table right there, right? And so I can see that when x is -4, y is 32, and so forth. And you'll notice that these numbers, I can go down to I can go down to +3. Did you guys notice that these numbers are symmetric? 3 and -3 both go to 18. And 2 and -2 go to 8. You know, you notice that those are symmetric. Okay, so you can get the table that way as well. All right? And then we can look at the graph and see what the graph looks like of that. If I wanted to compare it to another one, I can put the other one on, here, I'm going to go x squared this time. Just x squared. And if I want to compare that one, there's the graph. You can see that 2x squared is narrower than -x squared. You can also see on the table, if I go to the table, it shows me both of them at the same time. You can see when x is -3, y1 is 18, whereas y2 only goes up to 9. So you can see that y1, the 2x squared, is growing at a faster rate. Can you see how you can compare those than just x squared? So y1 is 2x squared, y2 is just x squared. So you can see how they're growing at different rates. Does that make sense? Now, I'm going to show you some other things right here. What I'd like everybody to do is I want you guys to see and make predictions. Okay? Raise your hand if you know what y equals x squared looks like, where it's going to be on the graph and so forth. Where's that going to be? Okay. Okay, we know that one's going to be, in fact, if I go to my y equals and I clear that out, we all know that x squared looks like this. Okay, I want all eyes up here now. I'll let you guys can finish the task later. The task isn't as important now as this. So all eyes right here. Okay, y equals x squared looks like this. Okay, this point right here at 0, 0 is where the parabola comes down and stops from going deep down to going up. That point right there is called what, everybody? The vertex. Now we're going to see how the vertex moves. We want to see how the vertex moves. So if I take, oh my word, these guys do that. Oh, there's a couple of girls that come in here every day at lunch and move my stuff around. So there it is. Thank you. Anyway, okay. They hide my tiger. They change my tigers every day. Do you guys notice my tigers are in a different place every day? Okay. Huh? There's one right there today. Okay. So my tigers are in a different place every day. Oh, it's right there. It stares at me when I sit in my chair. Okay. So, and then they change these things all the time. So, okay. So my vertex is at 0, 0. I want to see how it moves. So I want to make a prediction. I want to see. Just raise your hand. Do not say it out loud, Alex. Do not say it out loud. Okay. Ready? Everybody make a prediction. When you think you know where the vertex is going to move to of this one right here, raise your hand. Okay, raise your hand if you know where the vertex of that one's going to be. Y equals x squared plus 4. I want an x and a y coordinate. I want you to say the x and y coordinate of the vertex, and then I want you to tell me which direction it went up. Okay, Kurt. What's the x and y coordinate? 0, -4. What do you guys think? Okay. Caitlin, what do you think? 0, +4. So which way does it move, everybody, at once? It goes up 4 units. X squared plus 4 moves it up. Now, I know you're probably getting mixed up between the horizontal shifts. Okay? This does a vertical shift. If I add 4 to the whole function, here I had x squared, and I'm adding 4 to the whole function. I'm moving it up, right? I'm adding 4. Okay? We can show you. Go to the graph right here, and we can put in x squared plus 4. And if we graph that, it moves it up 4 units, right? Okay, raise your hand if you know this one. I want to name the vertex. Where is the vertex? And then where is... He can't help himself. So, okay, Kelvin. Whoa, hey, shh. Grant. Shh. Okay, Kelvin's going to say something. Go ahead, Kelvin. 0, -3. Raise your hand if you agree with him. All right. So it shifted the graph which way? Down how many units? 3 from x squared. Okay, next one. Next one, here we go. Raise your hand when you know where the vertex of this one is. Where the vertex of this one is. Okay? Raise your hand if you know where the vertex of this one is. Brendan. Brendan, right? Okay, Hutchings. Brendan. Okay. -1, 0. Raise your hand if you agree with him. Okay, that is right. When we're inside the parentheses, it does a horizontal shift. Which way is horizontal, everybody? Left and right. Think of the horizon. What's a horizon? The horizon is those mountains over there. That's a horizon, right? Okay, it's non-straight, but a horizon is where the sun comes up over. It's left and right. Okay. Okay. Now. Okay. McKenna, what'd you say? Do you remember when you were doing this on your task sheet right here? When you had x plus 1, it shifted it to the left one. So watch. We'll do this right here. We're going to change this one to parenthesis x plus 1 squared. Okay? When I graph x plus 1 squared, it shifts it to the left. Did anybody figure out why? Christian. Okay, come up here and explain that to everybody. That's a good job. Okay. Everybody, Christian is going to explain. I want you guys to listen very carefully.
Here, if you put in 0 for this equation, the answer is going to be 1. So you have to put 0 with the 1. So if you go to the left, when it starts coming up, it's going to end up on 1 when it's 0. If that makes sense.
I thought it was a good job. Okay. I'm going to let you guys think about it a little bit more. In fact, if you guys really want to understand it, what you need to do is make a couple of tables yourself without putting in your calculator of x plus 1 squared or x plus 5 squared, and you'll start seeing the idea of what's happening. Okay? Just know this, for right now, suffice it to say that if it has a plus something inside these parentheses, it's going to shift it to the left, right? Got it? Okay, just like that right there. Shift to the left 1 unit. Okay, next right here. Raise your hand if you know where the vertex of this one is going to be. Raise your hand if you know where the vertex of this one is going to be. Raise your hand if you know where the vertex is going to be. Okay. All right, McKenna. 3, 0. What do you guys think? She right? She's right. Okay, it's going to shift it to the right 3. Look, I'm going to change this to -3. X minus 3 squared. Shifted it to the right 3 units from x squared. Do we see that? Okay. Are we starting to get the idea? Okay, next one right here. You guys are getting so smart. Okay. What is okay, where's the vertex of that one going to be? I'm trying to throw you off here. Trick question. No, it's not trick. It's straightforward. It's like the bell work one. When you think you know, raise your hand. Hey, all eyes right here, you guys. You got to be thinking about this right now. Where is this going to be? Y equals x plus 5 squared plus 2. Where is the vertex going to be? Okay, Roger, what do you think? Negative 5 comma 2. Raise your hand if you agree with him. Yeah. Now all of a sudden we've combined these, right? The vertex is going to be at negative 5 comma 2. Okay. The vertex is going to be negative 5 comma 2. Remember, this shifted it to the left 5. This shifted it up 2 units. I'm afraid some of you guys aren't getting this because you're not watching. Okay? You guys got to listen. Some of you guys aren't watching. Some of you guys got it down. Some of you are still trying to figure it out. Okay, everybody, on this one right here. Y equals x minus 8 squared minus 3. When you know where the vertex of that one's going to be, raise your hand. Raise your hand when you know the vertex of that one. Okay, Jacob, what do you think? 8 comma what? 8 comma negative 3. Raise your hand if you agree with him. Okay, good. Watch. I'm going to put this one in there. Okay, so we have x, or parenthesis, x minus 8 squared minus 3. We graph that. So it went to 8 comma negative 3 is where our vertex moved to. 8 units to the right, 3 units down. We can see that right there. 8 comma negative 3 is the vertex. Are we understanding this? Okay, I'm going to throw you guys some different ones. Here we go. Y equals negative x plus 4 squared minus 3. Raise your hand when you know where the vertex of this one is going to be. Where is the vertex going to be? Okay. All right. I'm going to ask Alex. He thinks it's going to be at 4 negative 3. Is that what you said? Raise your hand if you agree with him. At 4 negative 3? You guys? Even though the negative is outside there, it's not going to affect this. It's still going to be negative 4, negative 3. It's still going to be, watch. Hey, you guys, how does the negative out front affect it then? Well, it doesn't affect the vertex, but how does it affect the graph? It flips it down, doesn't it? It makes it go down. So let's look at this one. So we're going to have, I'm going to insert a negative right here. Whoops, I hit the wrong button, so I'll clear it all out. So negative, parenthesis, x plus 4 squared minus 3. Hit the graph, and there it is. It's still at negative 4, negative 3. It's just going down instead of up. Raise your hand if you understand that. Okay. It's still the same place. All right, one last one, or a couple last ones maybe, right here. We just did something like this. What's that going to do, you guys? Make it skinnier because it makes the slope steeper, right? Do we understand that? Okay. And what's the only difference between this one and that one? It's flipped. This one's opening down. Anytime there's a negative out front, it's just going to flip it so it opens down. Do we understand that? Okay? All right. That's enough of that. So any questions you want to ask right now about... Okay, everybody write this down right here. This is called... Are you trying to get rid of that thing?
Yeah, I'm trying to break it, but it's not working.
Here, I'll take it. I'll take it seriously. Okay, put it away because it's driving me nuts. All right. Okay, here we go. You guys, what we've just been talking about are transformations. You've learned these things right here. If we compare all these to y equals x squared, and maybe I should write it like this, f of x equals x squared. This is less than 2.1, module 2.1. Okay, your notes. Y equals, or f of x equals x squared. We learned, first of all, what happens if you add a constant k to f of x. What happens when you add a constant to the function? Shifts it vertically up, okay? Okay, up. I'm going to just put up. What happens? Let's suppose that k is always positive, okay? Let's say k is always positive, because that's a good point. What if we minus k from it? What's it going to do? It's going to shift it down, right? K units. What if we do this? F of x plus k. Shift it to the left. And what's this going to do? Replace x with x minus k. It shifts it to the right. And last one. What happens when we times k times f of x? Well, if k is greater than 1, it makes it k is greater than 1, it makes it narrower, okay? If k is greater than 1, it steeper slope, right? Steeper slope or narrower. And if k is between 0 and 1, it is wider. It makes it wider. I like using the word wide. Okay? If it's negative, it just flips it upside down, right? So if k is negative, so if we go negative k times f of x, it opens down, right? Put opens down. By the way, this also goes for timesing k inside the function. It just does it at a different rate. Like, for instance, if I did f of k times x, f of k times x does the same thing as k times f of x. It just doesn't do it on nearly the scale, okay? It just does it at a different rate than the other ones, okay? So that's what we should have learned so far. Okay? Wider. What'd you say? Wider parallel. It makes it go like this. For instance, let me show you guys. If I had 1/2 x squared, 1 divided by 2, x squared, and I hit graph, here's 1/2 x squared, and here's x squared. You'll notice 1/2 x squared is wider, right? Not as steep a slope. Okay? All right. Now, we're going to quickly go through all these right here. We should know most of these by now. Okay, and I am going to put a graph over here to kind of explain most of these. Okay, so first of all, a vertex. I'm going to say I have a vertex like right here, and I'm going to say it goes up like this parabola. Okay, something like that. Okay? I didn't mean to make a point. It's supposed to be rounded. Say that again. Yeah, let's do that. Let's label these. So this is probably the best way to do it. Let's label them. Okay, the vertex is that point right there, right? It's x comma y. It's a xy coordinate. In this case, it's 3 comma 2. Okay, the vertex is 3 comma 2. What is the axis of symmetry? Does anybody know? It's a straight up and down line, but where does a straight up and down line go? Right through what? Right through the vertex. That's right. Okay, so this is the axis of symmetry. Why do we call it an axis of symmetry? Yeah, exactly. The right side of this parabola is symmetric to the left side. If we were to fold, because if this was a piece of paper and we were to fold along that line, the left and right half would match up to each other. Does that make sense? If we folded it up, this part right here on the right would fold over onto the part onto the left. They would coincide. Okay? That's called the axis of symmetry. So this right here is called axis of symmetry. Okay. Maximum or minimum? Yes. Anybody know what a maximum or a minimum is? Does this parabola have a maximum or a minimum? Has a minimum. It's the minimum point. Where is that minimum? At the vertex. Is that what you're saying, Kelvin? Okay, yeah. This thing has a minimum. Because if a function opens up, the vertex is a min, or a minimum. If it opens down, the vertex is a maximum point on the graph. No, you do it by the x and y coordinate. It's the vertex. If you want to know what the max is, it's going to be the y coordinate, because the min and max tells how high or low it is too. Okay? And y tells how high or low something is, right? X tells how far left and right it is. Okay, so we have a minimum point and we have a maximum point. Then we have an equation of the axis of symmetry. See this right here? What's the equation? How do you write an equation of a vertical line? No. Y equals x is a line, diagonal line. No. No. Let me ask you this. Is a vertical line a function? It's not. So it's not going to be y equals something. It's going to be x equals 3 in this case, right here. This one right here is x equals 3. And so it's always going to be x equals, let's say a, whatever the y coordinate is. I mean the x coordinate is. X equals a, and a represents the x coordinate. Okay? What do you think x-intercepts are? Okay. Where it intersects the x-axis. The one we have up there doesn't have any, does it? You'll notice that the one up here does not have any x-intercepts. How many x-intercepts can a quadratic equation have? At the most 2, right? What's the least number it can have? 0. Can it have 1? How? Yeah, if it touches. Okay? So it can have 0, 1, or 2 x-intercepts. Okay, last thing, vertex form right here. Vertex form is this. F of x equals a times x minus h squared plus or minus, well, plus k, we'll say. Okay, a times x minus h squared plus k. Have we seen this form today? Why do we call this vertex form? Yeah, it tells us where the vertex is. This form of a quadratic equation, do you guys notice these are all quadratic equations? This form of a quadratic equation tells us where the vertex is. Write that down. Tells where the vertex is. Tells, I'm going to move this up for you guys. Does that help? Tells where the vertex is located. Okay, that's what it gives us. So how many x-intercepts can a quadratic have one more time, you guys? Most. 2, least. And it can have 1, right? Okay, we're gonna do a couple examples right here. Are we ready? I know I'm always in the way for you guys, sorry. I probably should leave that table empty and have you guys sit over there. So, okay, I'm actually gonna be changing your tables here soon. You guys are gonna be changing people, and let's vote on this. All right, here we go. Okay, everybody ready? In your notes, write the following down based on this graph. Okay, A, put down A, the vertex. Write the coordinates of the vertex. You're gonna have to move quickly with me. Write the vertex. A is vertex. B, the the axis of symmetry. Write down the equation of the axis of symmetry. C, write down the x-intercepts. C is the x-intercept. So one more time. A is the vertex. B is the equation of the axis of symmetry. C is the x-intercepts. And if A was 1 on this, what would be the vertex form of this equation? D is the vertex form of this equation. Vertex form of this equation. D is the vertex form of this equation. A is the vertex. You're supposed to write the vertex form of the equation. What do you mean where? It's not written on there already. You got to write it, Grant. You weren't listening when I was talking about that part. B is the equation of the axis of symmetry. C is the zeros, or the x-intercepts. The x-intercepts. They're also called zeros. We'll talk about that later. And B or D? B as in boy? Axis of symmetry equation. Okay, let's see how many of you got it right. Okay, the vertex is at -3, -2, right? B, the equation of the axis of symmetry is x equals -3. It's this line right here. Notice that every x coordinate on it is -3. It goes through -3. It goes through the vertex. So it's got to be the x coordinate of the vertex. C, it goes through -1 is one of the, x equals -1 is one of the x-intercepts, and x equals -5 is the other one. Okay, and D is vertex form. And I said assume that A is 1, so it's going to be x plus 3 squared minus 2. How many of you had all 4 of those things right? C is the x-intercepts. The x-intercepts. Okay? So did we get them all? All right. Hey, you guys, here we go. Do the same four things on this one. A, the vertex. Justine. Of the axis of symmetry. The equation of the axis of symmetry. The axis of symmetry is the line, the vertical line that goes through the vertex. So it's always going to be x equals whatever the x coordinate of the vertex is. Huh? Of the axis of symmetry. Well, no, the axis of symmetry is the vertical line. The equation is x equals -3. Okay, does that clarify it for you? Okay, you guys, A, find the vertex. B, the equation of the axis of symmetry. C, I want you to find the x-intercepts. And B, the vertex form of the equation. Okay, here we go. Y, oh wait, sorry. Question A is 2, 4, right? B, no, the vertex is at 2, 4. B is x equals 2 because every x coordinate of the axis of symmetry is 2. C are the zeros where it crosses 0, which is x equals 0 and x equals 4. And D, the vertex form of the equation, would be f of x, or y, doesn't matter, equals negative, why negative? It's upside down, that's right. X minus 2 squared plus 4. How many of you guys got all 4 of them right? All right, how many of you missed one minor thing? What'd you miss? Yeah, don't forget, this is always opposite sign, right? This one's always opposite sign. Are you guys catching on? Because this parabola is opening down. A is -1. -1. This one was +1 because there's no number there, right? No. Remember, A changes how wide it is or narrow it is, right? And right now I just did 1s on these. I told you just plan on 1s. And I said the absolute value of this one's 1, but it was negative, okay? All right. Hey, you guys. Everybody look at this. Is this a maximum or a minimum? Minimum. What's this? Max. We got them down? Okay. Hey, you guys. Let me ask you this. What is that? If you know what this simplifies to be, raise your hand. Do you know what that simplifies to be? Raise your hand. We're going to lead into this later on. Okay? All right? Okay, what is it, everybody? Hey, look it. A square root and a square undo each other, right? So it's just x minus 2. Got it? Okay, what about this one? (25x squared y to the 4th). The square root of 25x squared y to the 4th. If you know what it is, raise your hand. The square root of 25x squared y to the 4th. 25x squared y to the 4th. Y to the 4th power. X to the 2nd power, y to the 4th power. Shaden, what do you think it is? 5xy squared. That is right. Because the square root of 25 is 5. If you take the square root of x squared, it just becomes x. Why? Is that what you asked? Because the square root of x squared, the square root is undoing the square, right? Okay, and the square root of y to the 4th can be written as y squared squared, right? So you take the square root of y squared squared, you take off that first square. They undo each other, so you'll leave with y squared. Got it? Okay, you guys are ready for your assignment.